Hi guys, welcome to my YouTube channel Chem Villa. Today I am going to record second part of empirical formula where I am going to take few more questions related to empirical formula. Okay, so let's see this question. In this question we have to find the formula of oxide 2. So what is the question exactly? Certain non-metal X forms two oxide 1 and 2. The mass percentage of oxygen in oxide 1 is 43.7, which is same as the mass percentage of X in oxide 2. Find the formula of oxide 2. We have to find the formula of oxide 2. So let's first write what is given to us. What all oxide is given to us? 1 and 2. And what is the mass percentage of oxygen in oxide 1? Is 43.7 given here. And what is the mass percentage of X? So we have been given in the question, which is 43.7, which is same as the mass percentage of X in oxide 2. So in oxide 2 X is 43.7, and besides this we have been given the formula for oxide 1, which is X4O6. Right? Now let's see how to do this question. We have the mass percentage of oxygen as 43.7 in 1. So what will be the mass percentage of X in oxide 1? We will simply subtract 43.7 from 100. It will be 56 point. Similarly, we will find the mass percentage of oxygen in oxide 2 by subtracting 43.7 from 100 again, and we will get the answer as 56.3. Okay. Now see, we know that 43.7 parts of oxygen is equal to 6 atoms. How we know this? In oxide 1, 43.7% of mass percent of oxygen is present, and in oxide 1 we have 6 atoms of oxygen. It is given in the molecular formula. So 43.7 part of oxygen is equals to 6 atoms, right? Therefore, this 56.3 mass percent of oxygen will be equal to how many atoms? This is simple unitary method, right? This 56.3 parts of oxygen is equal to 7.73 atoms. Now similarly we will find out the number of X atoms in oxide 2. So for the number of X atoms, 56.3 parts of non-metal X is equal to how many atoms? It is given, right? 56.3 part of metal X in oxide 1 is equal to how many X atoms? 4 X atoms. Right? So 43.7 parts of X in oxide 2 in oxide 2 will be equal to how many X atoms? 3.1 X atoms. Now, since we know to find out the empirical formula, we were dividing each value with the least value. So the least value is here is 3.1, right? So we will divide both the number of atoms found here with the least value. So the ratio of of X is to O is proportionate to 3.1 divided by 3.1. As I mentioned, we will divide both the value with the least value, and 7.73 divided by 3.1. Now, so x is to, upon calculation, upon simplification, x is to O is proportionate to 1 is to 2.5. Now we know that any formula should be, any molecular formula or empirical formula should be in whole number. It cannot be in decimal. So we will multiply this ratio with a factor. Right? Let's multiply this ratio with a factor of 2. Why 2? Because 2 will give us a whole number. If we multiply 2.5 by 2, we will get 5. So 2 is giving us a whole number. So we will multiply this ratio with 2. 1 into 2 is 2. And 2.5 into 2 is 5. Therefore, x is to O is present in the ratio 2 is to 5. Now to find out the formula, what we will do? Simply x is corresponding to 2. So x 2 and O is corresponding to 5, O 5. Therefore, the formula of oxide 2 is X2O. Now, moving to our next question. The next question is, what is the simplest formula of the compound which has following composition? C is equals to 80%, H is equals to 20%. If the molecular mass is 30, calculate its molecular formula. Guys, I request you to please read the complete question, because most of the time what students do is they do the first part. They know the full question, how to do it and what will be the answer, how to proceed with the steps. They know it. But what they do in a hurry, they just do the first part and they just forget about the second part and lose their marks. This is the key point where most of the students lose marks. So we have to cover second part also. Read the question in the question paper very clearly and completely. Do not just read the first part. Okay. Now, in the first part of the question, we have to calculate simplest formula. Simplest formula is empirical formula. So, the compound composition is 80% and 20%. So, I have explained how to calculate empirical formula in part 1 of the video. I will share the link in the description box for the part 1. But if you find any difficulty in finding out the empirical formula for this question, please let me know in the comment box. I will explain them how to find out empirical formula for this question again. When we will find out the empirical formula, we will get CH3. Now, read the second part. If molecular mass is 30, calculate its molecular formula. In part 1 of the video, I explained that molecular formula is a multiple of empirical formula by a factor of n. Right? So here we have the molecular mass and we can find out the mass of the empirical formula. Right? Can't we? Mass of molecular formula is 30. Mass of empirical formula, I am writing in short form, but this is not the accepted form. So you have to write completely in the exam. So mass of empirical formula is 15. Mass of molecular formula is 30. Now see, molecular formula is a multiple of empirical formula by factor n. So whatever will be the molecular mass will also be a multiple of empirical formula mass by the same factor. When we will substitute molecular formula by molecular formula mass 30, we will keep the factor as n because we don't know what is the factor, and we will substitute empirical formula with empirical formula mass. Then the factor will come out to be 2. So therefore, since we know empirical formula is CH3, we will multiply, and molecular formula is a multiple of empirical formula. We will multiply each atom by the factor of 2. So therefore, our molecular formula will come out to be carbon atom is how many carbon atoms are there in the empirical formula? 1 atom is there. So 1 multiplied by 2 is C2. How many hydrogen atoms are there? 3 hydrogen atoms are there in the empirical formula. So we will multiply 3 by 2. So hydrogen atom will be 6 in the molecular formula. Therefore, the molecular formula of mass 30 is C2H6.